Okay, there's not a side angle combination. So you can see that there's not a combination of a side of the angle opposite that side. So I can't use the law of sines, but I can solve the triangle. I just need another formula. Law of sines is not going to work for me. So today we're going to learn the law of cosines. Just a reminder, from geometry, I don't know why this I think it might come up on a homework question or something. I'm not really sure why I threw this in at this point. Any two side lengths of a triangle must be greater than the third side. That does come up on the ACT every now and again. Otherwise, it wouldn't reach to make a triangle if the other two is the shortest distance between 2 points in a straight line. The other two weren't longer than that third side. It wouldn't make a triangle. Okay, this is what we're learning today, and it's called the Law of Cosines. I have 3 formulas here. I would argue that it is a complete waste of your time to write any down besides one of them. Why? They're all the same thing, except variables rearranged. So, it does work for any of the 3 sides of a triangle. A squared equals b squared plus c squared minus 2bc cosine of a. So this is for any triangle. Now, where this will be useful for is for side angle side, which is what the bell ringer was, right? Wasn't it a side angle side? And it's also useful for side to find an angle. So those are the 2 cases where the law of cosines will be necessary. You will need to memorize this formula. How did you see this formula on the ACT? They usually give it to you. They say, here's the law of cosines. Solve this problem. And it looks really hard and scary, but they show up sometimes, and sometimes law of sines show up. You know, in those 4 trig problems, there are some that occasionally. There's a note at the bottom if C is 90 degrees, or if any of the angles are 90 degrees. What is the cosine of 90 degrees? 0. So that whole piece drops out, and you have the Pythagorean theorem, which makes perfect sense. That this is the Pythagorean theorem, just as an yes. So this does work for any triangle, not just triangles. You can memorize only one of them, and then just use the appropriate angle in the place it needs to go. It's supposed to be Tuesday, but we tried to move it to Monday because Tuesday was short. Really quit doing that terrible break.
So what's Tuesday?
There's
yeah.
We are very close. We have today's lesson and then tomorrow's lesson, and both of them are much easier than the last 2 days. The law of sines with 2 triangles gets tricky.
Well, I think it's kind of easy because it gives you basically your answer. You just have to.
I'm glad. This is the problem from the bell ringer, right? So now I would argue we can find it. It says 2 boats leave a harbor at the same time, traveling on courses that make an angle of 82 degrees 20 minutes between them. When the slower boat has traveled 62.5 kilometers, the faster one has traveled 79.4 kilometers. At that time, what is the distance between the 2 boats? So in a long, drawn-out word problem, they've asked me to find side C. And we said on the bell ringer, there's no way to do this with the law of sines because I don't have a side angle combination. But I can now use the law of cosines. Which formula, which is again really all the same formula, but which one would I pick to use? C is the side I want to find, and C is the angle I know. And really you're going to base it, if you have a side angle side case, you're going to base it off of the one angle that you know. And so I know angle C, so I'm going to use
A squared plus B squared
C
plus 2AB plus BC plus C.
I'm going to use. C is the angle. A and B are the other two sides. Plug it all in and take a square root. Why am I going to take a square root?
Square.
It's C squared, and I just want side C. That's how the formula works. For finding a side. We will need to find an angle on the zero. Side A is 79.4 squared plus 62.5 squared minus 2 times 4 times 62.5. Cosine of 82 degrees, 20 minutes. Does everyone remember how to type that in your calculator? It is under second. Is it second? After.
Second, perhaps.
Okay, now remember that C squared. Now if I were taking some time in my calculator, I would go ahead and type that in all under a square root. And so you get C is approximately what you say. So what everyone got? Think if it's, decide if it's reasonable. We only have one angle, but probably 82 is the biggest angle in this triangle. Definitely looks like it based on the picture, right? So it makes sense that you would get a side larger than the other two sides. Any questions about that one? Okay, any questions about that one?
I'm confused on when you use law of cosines.
Okay, try to use the law of sine. Now, there are two cases that law of cosines is going to be most useful. It's side angle side, when we're given a side with an interior angle on another side. Again, because we don't have an opposite. And then the other case is side, side, side. Those are the two cases that you're going to want to pull law of cosines. Yes, ma'am. Not getting the correct answer. So it's 82 degrees, 20 minutes, not 89 degrees. Okay. So this is another one, very similar. It does say solve the triangle, so it does want to find all of the sides and angles in the triangle. You can draw a triangle if you wish, but you don't have to. You can just use the formula from there. I'm going to go ahead and draw a triangle just for fun. This is side angle side. Does everyone agree? A, 28.2, and I have side C, which is 46.7. And again, try the law of sines, right? If you can use the law of sines, use the law of sines. But why can I not use the law of sines? I don't have a side angle combination. So remember yesterday, this side was up here. Remember that side was up there. So I have that side angle combination, and I can use the law of sines. So I can't, so by default, I'm going to use the law of cosines. I can always do one of the two. Any questions so far? So I'm going to do side B. Okay, if I go ahead and make it a square root. That's not okay. Okay, square root in there. 28.2 squared plus 46.7 squared minus 2. That's 28.2 times 46.7. Cosine 70.5. All of that in your calculator, and it will give you sine.
Let's see.
47.2. Store that value in your calculator or go back up and grab it. Does everyone know how to use the store button? If you want to store that, you push right now, as you have that answer sitting there, you push store, and I would probably call it B if I were you, since it's side B, so I knew what it was. And so you could store as alpha B and push enter. That way, when I use that side later, it is a stored value. As you can probably tell, to solve the entire triangle, am I going to have to use that side at some point? Yes. I need to find an angle. I do have options. I can use the law of cosines, or I can use the law of sines. Okay. Before I pick law of sines, I do want to tell you one danger in the law of sines and how to avoid it as you go forward using solving triangles. Sine inverse cannot find obtuse angles. Do you agree with that? We learned that yesterday. Sine inverse is not capable of giving you obtuse angles, right? Cosine inverse is, because it gives you angles in the first and second quadrants. So cosine inverse will give you obtuse angles. Sine inverse won't. So what I would always do is when I use the law of sines to find an angle, this will really more matter with side triangles, I would pick the smallest angle first. That way I know it's not obtuse, because how many obtuse angles can there be in a triangle? Only one. Get the other two angles, subtract from 180. So save the obtuse angle for last. Does everyone know what I mean by that? That way, if you're using law of sines, it's not a problem. Now, law of cosines, if you keep using law of cosines the whole time, it will never mess you up. However, law of cosines is a little bit more tedious than the law of sines. So, one danger, never use law of sines to find an obtuse angle. Now, don't get me wrong, we could find it by subtracting from 180. We did that yesterday. But we would rather not have to do that. So, just make that the last angle. So, I'm going to use that side B. And the angle that I have with it to find angle A. Why would I pick angle A?
It's so cute.
It's small. How do I know it's a small angle? Yes, it's the smallest side, so it's smallest angle. So I'm guaranteed that it is smaller than the other angles. That means I know it's not obtuse. In fact, I even knew that angle is not obtuse on this one. So on this one, it wouldn't have mattered. I couldn't stop either of the two. But just thinking going forward, it's always safe to find the smallest angle first. Okay. Multiply by 28.2 and then do sine inverse. Someone with a calculator find angle A. Negative 34.94. Okay, sorry. Not negative. It's positive. Check that for me.
Yeah.
Any questions about that? Okay. And then how would you find angle B? Or angle C, sorry. Subtract from 180. I probably wouldn't do the law of sines again because I know there's a danger. Now on this one there is no danger, but on some there's a danger of that one angle thing. So find angle C and what you get. Okay. Any questions about that? Okay. That's how you use the law of cosines to solve an entire triangle. Now again, we only use the law of cosines on one part. The other parts we use the law of sines. Questions? Okay. Solve the triangle given side, side, side. Here's the one where I have to be careful. There are two ways you can avoid any dangers, and I'll talk about both of those ways. I need the law of cosines now to help me find an angle. So I don't need a side, I need an angle. But I could use any of the three formulas, agreed?
Agreed.
Cosines, the law of cosines can give me an obtuse angle. So if it were me, I'd do that one first. Get that out of the way with the law of cosines. That way when I do the law of sines, everything else is acute and I don't have to worry about it. If you don't do that, then just be careful that the second angle you find with the law of sines is not the obtuse angle. So just be careful. Obtuse angles, law of sines, bad idea. Obtuse angles with the law of cosines is fine because cosine inverse will give you an obtuse angle. No problem. So I'm going to start with finding angle C because I know that the law of cosines won't mess me up. Or I know that the law of sines has issues with those supplementary angles. And I'm finding an obtuse angle. So I'm going to choose side C equals A squared plus B squared minus 2 times A cosine of angle C. And I'm going to solve this for C. I will tell you that this is, star this in your notes. This is not difficult, but very commonly messed up by students. The thing that students want to do is go ahead and combine all of this stuff together. Someone tell me why you can't do that.
Part and multiplied by cosine.
The part in the end is multiplied by cosine of C. So this piece right here, I can't touch it right now. I mean, I can multiply 2 times 25.4 times 42.8, but I can't do anything else. Does everyone understand what I mean by that? So to solve this, would you agree I need to subtract over the other two? Yeah. And I'm going to do this without getting the numbers yet, but go for it in your calculator, get the numbers. You're okay with me doing all of that at once. So I want to multiply or subtract over the two other pieces and then divide by the piece multiplied by the cosine of C. If you look in your textbook, there will be a formula that looks like this. C squared minus A squared minus B squared divided by negative 2, what did I do, A and B? Negative 2AB equals cosine of C, or they may even put a cosine inverse in front of that and call that C. A lot of teachers have people memorize two formulas because so many people mess the algebra up on here. If you know you might mess this algebra up, memorize that other formula. If you're pretty good at algebra and know that you wouldn't combine that stuff, then subtract over, divide. It's not too terrible. Just keep that in mind. Does everyone know what I mean by that? So just be careful, start in your notes, be careful on that step. Type all of that in your calculator and do cosine inverse of it. And you notice that is obtuse. I expected it to be obtuse. If you accidentally do the law of sines or something and you don't get the biggest angle opposite the biggest side, you did something wrong. Try again. Just something to keep in mind as you're working that the biggest angle should be opposite the biggest side. Now that I have that angle, I can use the law of sines from here on out. So the hardest thing with law of cosines, make sure you are careful with obtuse angles. Other than that, formula. So we have, let's see, sine of 118.561. Use that stored value in your calculator. Over, that was angle C, so over 59.3 equals the sine of A over 40. Sine of A over 24.5. Again, thank you. Multiply by 25.4, do the sine inverse. Am I going too fast? Sure. That was this angle here. So I typed all of this in my calculator and I did cosine inverse. Try it. See if we can. It's not using the error. Yeah. When you divide by this, don't use a 2 bar.
Yeah. One. I did it small. That's not.
What did we get for angle A?
Yeah.
I already wrote 24.5. And then how did you find the third angle? 180 minus both of those. 39.3. Any questions about those? About a side. So those are the two cases where we need the law of cosines. We need it for side angle side. We need it for side. This is your homework. We'll do one more example. We'll make the lecture good to go. 298, 28 through 36.
Is this tomorrow?
The same as the one that was.
Just do tomorrow and stuff.
We can grade it on Thursday. Tomorrow we will learn our last new lesson. We'll get one more new homework tomorrow. And then on Thursday we will be reviewing for the test that's on Monday. The review assignment will be on Friday. So you might want to kind of get your stuff done so that you're only working on but that's up to you. So you'll get a review assignment on it. I might hand it out tomorrow, but it won't get you until Friday. Test is on Monday. But I would go ahead and start this homework. Make sure you know what you're doing. Find the measure of angle C. If I'm only finding one angle, do that one first, right? There's no reason to use the law of sines or any other work. Just find that angle first. It's not obtuse, but it would matter in the law of cosines anyway. If you get stuck on the test, no, I wouldn't recommend it because it'll take you a long time. But you could use the law of cosines to find all three angles, and then you would never have to worry about which one was obtuse because it'll answer correctly every time. But yeah. So this one, no, I only want angle C, so I'm not going to start with an obtuse angle because I only want one angle. So I'm just going to answer that one angle. Since I want angle C, which setup do I use? C squared equals A squared plus B squared. I did that backwards, but it doesn't matter. So find angle C. So I want to see if y'all can do the algebra without my help. Just make sure you never combine the 6 squared plus 11 squared and the negative 6. It has a cosine of this, so you can on the test, make sure you do write down some work. That way, if you miss the answer, I can give you more credit points.
Is it okay if we just solve the top?
I'm okay with it either way, but like I said, show some setup. That way, if you write down 6 wrong answers, or, well, 3 wrong answers, it's not 0 out of however many points are on the test. You show the setup, but you just typed 25.4 instead of 24.5, you'd probably get 4 out of the 5 points, or whatever that would be in that problem. Where if you showed no work, you got a wrong answer, I didn't know where it came from. Cosine inverse of that, and what did we get?